Hello, and welcome to an Orange Coast College math skills video. In this video, we're going to be looking at factoring the greatest common factor, or GCF for short, out of a polynomial. Now, before we get started, I'm going to assume that you're comfortable with multiplying monomials and polynomials and the distributive property. Okay, let's start with an example, and then we'll look at how we did it. So the first step, we have this polynomial. The first step is looking at each term, the things being added or subtracted. So this is a term, this is a term. We have two terms in the polynomial. We want to look and identify each type of factor in each term, the factors, the things being multiplied. So what are our types of factors in our terms? So we have numerical factors, right? In each term, we have a 6 in the first, 36 in the second, and we also have powers of x. Now, the greatest common factor is we look at each type of factor and we look at all of the factors that each term has in common. Okay, so we have numerical factors in common. We have 6 and we have 36. And we also have an x is in common, right? We have x and x to the fourth. So the greatest common factor is simply just take the largest factor of each type that's in all of the terms. So for numerical factors, what factor does each one have in common? It has a 6. Okay, because we have a 6 in the first term, 6 times 6 is 36 in the second term. For the x, what is the largest power of x in each term? Let's see, we have an x to the fourth in the first, x cubed in the second. So the largest power of x in each term is x cubed. And that's the greatest common factor. Now, to factor the polynomial, to factor that out of the polynomial, all we have to do is from each term, what is left over once we've removed this GCF? Well, we don't have a 6 anymore from the first term, and we had x to the fourth, and if we remove x cubed, we'll have a factor of x left over. From the second term, 36 is 6 by 6. So since we removed a factor of 6, we'll have a factor of 6 left over. And since we have a factor of x cubed, but we remove it, so that's it. And we're done. Now, if we want to check our work, we simply distribute the GCF back to each term. So if we multiply this by x, we get 6x to the fourth. And if we multiply 6x cubed by -6, we get negative 36x cubed. So if we distribute that, we're good. And that's it. What were the steps that we took in that last example? Well, first thing we did, we looked at each term and we identified the factors. Okay, so what factors do you have in each term? And it can really help if you write them all down. Step 2 was we figured out what was the GCF, all right? What factors did each term have in common, and what was the maximum power of each one of those factors? And finally, step 3 was to write down what's left. What is left over once I have factored the GCF from each term? And step 4, not written in this slide, of course, you can check your work. And when you check your work, you have your GCF, you just distribute it back to the 2 terms left over, or 2 or more terms left over. And we're just doing the opposite of factoring, right? The factoring is exactly the reverse of the distributive property. All right, and here we have a second example. So we want to look at each term and we want to find all of the factors that are in all of the terms. So first we have numerical factors. So we have -4, 2, and -12. Okay. We have factors of u squared, u. And finally, we have factors of v that are powers of v. So v squared, and v. All right, first look at the numerical factors. If we want to find the GCF of all the numerical factors, that's just the integer, the largest integer, that will divide each one of them evenly. So between -4, 2, and -12, the largest integer that divides them all evenly is 2. And then we have the u factors. We have u squared, u, and u. The largest power of u that they all have in common is u to the first. Okay, and then finally the v. So for the v factors, we have v squared, and v. The largest power of v they all have in common is v to the first. So 2uv is the greatest common factor. And now we have to just look at each term and see what's left once we factor that out. So what would I multiply 2uv to get -4u squared v? Well, I should have a factor of -2 left, a factor of u, and then no factor of v. Okay. For the second term, we factored out 2uv from 2uv squared, so the only thing left over will be a factor of v. And from the last one, we have 2 times negative 6 would give me negative 12. So maybe I can just put a negative sign here instead. And then we factored out a power of u and a power of v, so that's all we have left. Now, we could have, instead of factoring out 2uv, I could have also factored out negative 2uv, okay? And all that does is change all of the signs. So instead of having negative 2u for the first term, we would simply have 2u, then we would have minus v plus 6, right? If we factor out that negative 1 there, okay, it just changes all of the signs. And that's it. And again, feel free, check your work, simply redistribute that GCF back to each term to get the original expression. All right, here's our last example. Let's again identify the factors. So we have numerical factors. We have 5 and 2, although they don't have a common factor, right? The only number that divides 5 and 2 both evenly would be 1. And then we have a factor of a. We don't have a factor of a in the second term, but that's okay. We're just listing our factors. And finally, we have a factor in each term of a minus 4. Now, a minus 4 is a factor which consists of 2 terms. That's okay. Factors are the things in each term being multiplied. So we have that a minus 4 being multiplied by something in each term. All right, what is the GCF? Well, we have no numerical factors in common. We have a 5 and a 2, but the only number that divides them both evenly is 1. As far as a, what is the largest power of a in each term? We have an a to the first. We have no a here. So you can think of it as being a to the 0. So essentially, so far, our common factor is 1. Okay. And then for the last type of factor, a minus 4, we have a power of a minus 4 in each term. So we can factor out a minus 4. Okay. That's our common factor. That's our GCF, is a minus 4. Now, what will we have left over from each term once I've removed that? So if you remove the a minus 4 from the first term, you're left over with 5a. And if you remove the factor of a minus 4 from the second term, you're left with simply negative 2. And that's it. If you were to distribute this a minus 4 back, you'd have 5a times a minus 4 minus 2 times a minus 4. And that's it. And that's factoring the greatest common factor from a polynomial. Now, make sure you practice this a lot. Once you're comfortable with this, you can move on to factoring by grouping. Until next time, have fun.